Hello everyone, this is Abhishek Yadav and today we are going to see co- System Software and Compiler Lab Batch 5 Experiment number 5. So in this you have to stimulation of deterministic finite automata, that is DFA. So DFA has 5 tuples, that is Q, sigma, transition, Q naught and F. So Q stands for all possible transition, all possible states. Sigma is our all inputs which can be provided to the DFA. Transition gives us like this, like in that state, if the input is this, to which next state it should go. Q naught is the starting state and F is the final state, set of all final states. So for this, let's see the program. First, let us see it with an example. So I have already compiled. It is a C++ program, so I have already compiled, and let's see. So we are making a simple one. So let's start with if our DFA accepts it is a B. If a string has B, it will go to final state. Otherwise, it won't go to the final state. So for that, we would need only two states. So how many variables are there? So out of A and B, two. So it asks how many variables are there. So two. Enter your variable A and B. Enter your node name. So our node should be capital. On reading A, where it should go. So on reading A, it should go to the same state. It should stay in the same state. On reading B, it should go to the state B. And then node name 2, which is B. On reading A, it should stay at B and B. So this is our matrix which forms. So enter your starting state. So our starting state should be A. Enter how many final states are there. So as it is set, so it asks for how many final states are there. So we give 1. In this case, we have only B, and that is capital B. Enter your string. So now a string can be ABB. Valid input. Wanna try again. So if we press Y, we can try again with some unvalid input like AA. So it says nothing, that is invalid input, and then again asks for wanna try again. If you do know, we will exit. So let's see the programming for this. This is the main. So we have all first we ask how many nodes are there, how many variables are there, and then we store it in a variable array, and we take the input from the user for that many times less than v, and store it in a variable. So here all our variables are stored first. Then we have already taken how many nodes are there. So here we are going to take the nodes, and we are going to print that what you want on reading that variable, what you want. We are going to store it in an array. So the first one should be A0 AI. So here I have taken AI. The first one should be the name of the node, so which will be stored at 0th index, and after that it should be stored at ij plus 1. It should not be stored at 0, it should be stored plus next position. Then we are printing the table over here, and then over here this is just the print of the table. Over here it asks enter your string, which is in. Then we try to find out the size of that input, and we make a character array. We copy the all the input from in string in into a string copy, which is we made a character array input, and then we go from starting. So if less than, it will match that temporary variable. So what I have done is I have taken character as the starting state. So it asks for which is the starting state. So I have stored it in temporary variable t. So first it is going to match that t over here. So if it is matches, if it is a match, it is, if it is less than n, if it is it passes the greater n node, that means it is equal to n node. If it is equal to n node, then it is invalid input. Just break it. If same case with the variable, I've already taken it. So if first of all it will try to find out that that node is present or not, the starting state s or whatever. In this case, after the whole execution, we are transferring that. We'll see that later. First of all, here it is going to check then for variable. Then if it is equal to v, then that means that variable is not found, that is not in the string, so it cannot be accepted. After that, what it is going to do, that it is going to check at that position of that variable that what should be the transition, and we are going to store it at t. So when we store it at t, the next time over here when checking, it should go to the and check the t. So where that t is present or not, that the transition state, that state is present in the whole queue, capital Q, it is present or not. So and then the loop is infinite loop. If you press do while loop, so if you press y, it will keep on repeating again and again. That's all. Thank you for watching.